speaking from the Manual of Competent Communication. It's Project 7. And the speech name is Research Your Topic. Her speech is going to be from 10 to 12 minutes long. Prabhajot works as an engineer at General Motors. She's been with Birmingham Toastmasters for 7 years now. And as some of you know, she's been working on a PhD in computer science. Her thesis defense is scheduled for April 4th. Today she's going to be presenting a short version of her PhD final presentation, also called Defense. Some content may be more technical than you might enjoy or understand. She is looking for feedback on the relay of the problem statement and solution being proposed by her work. So please help me welcome Prabhajot Kaur, Ariel, Prabhajot Kaur.
After listening to 2 great speeches, this might not be so enjoyable, but hang in there, please. I'm at the final step of finishing my PhD degree, and this is rehearsal for a 45 minutes presentation that I will be giving, so this is 10-minute version of it. The topic of my research is autonomous robot for indoor enhanced living. And my advisor is Dr. Sangshi, who has helped me for all the past 6 years through my journey. Today's presentation, first I'll give a background of the problem that we solved or solving, the objectives and our contributions, and the research topics, precisely what we contributed to the literature, and then future directions and summary of the research. Right now, the entire population, the world population, is going through a demographic shift. So by 2060, we will have about 19% of global population that is 65 years or older. So as you can see here, this is called population pyramid. So if you see that it is fatter here, which means you have more older people. If it's fatter in the middle, that means you have more younger people. So this is a projection to 2060. What it means is, for America, we might have one in every 4 people who are 65 years or older. That is a challenge, because as we have older population, more older population, we will have less younger people to take care of the older population. So according to the survey by AARP, which is American Association for Retired Persons, seniors prefer to age in their own homes, in their own communities. That's called aging in place. But aging in place is not easy, especially for people who are living alone, because naturally there's a decline in mental and physical health. So we need to have caregivers. But caregivers are already in shortage, even today. Caregiving jobs are one of the toughest jobs to retain people, because maybe they're not good paying jobs and people don't see their career growth in those jobs. So we already have a shortage of caregivers. So we are going to have increase in demand for the long-term care because of the increasing population, but there is a shortage of caregivers already. So we are headed towards a strained long-term caregiving system where we will not be able to provide quality of life for our senior population. By the way, anybody in their 30s here will be one of those who might need long-term care.
Thanks.
So what can we do? So before we start proposing solutions, it's important to understand what does the target population want. So they do want to age in their own homes, which we call aging in place, and it does have advantages. It is cost effective because people don't have to spend money to go to nursing homes, and this is preferred way of how they want to spend their lives. And also it gives them independence. The challenges, of course, are the safety is at risk. It's hard to live alone, and a lot of individuals, older individuals, are living alone. And there are psychological impacts such as loneliness. And of course, we have a shortage of caregivers, so we cannot, even today, we cannot keep up with the demand that we have. So what we are proposing is technological innovations that can augment the existing caregiving system. So the design goals, before we develop any technology, it's important to understand what the target population wants. What are our design goals? So in our case, based on the user studies that have already been done, and also what the loopholes are in the current system, our design goals were 3. One was the technology has to be versatile, which means, let's say I buy a phone today that is supposed to just help me make calls, and then if I want to add on another application, maybe I have to buy a different piece of technology device. So versatile means if I have one piece of technology today, I should be able to add on more applications. The second design goal is privacy aware. This is one of the critical issues. All the devices like cameras, things like that we use for monitoring, seniors, most people don't like those because they invade into users' privacy. The third thing is it has to be inclusive. So as we age, we will have more diverse population. We'll have people who don't speak native language. We'll have people who didn't grow up here, not from the same culture. So the technology should be inclusive. In order to support these 3 design goals, the way we meet them is the first 2, versatility and privacy aware. We meet them by the virtue of our design choice, like how do we build the applications. And the inclusivity, this is met by the type of applications that we built. So our design choice is twofold. First is we chose a mobile robot that can act as a personal assistant for people in their own homes. The second is we specifically focus on the sound input. So our applications that we develop, we don't use the cameras to monitor, but we use the ambient sound to learn something important from the environment, which we'll go in detail. So this is our platform. It's a robot that has a camera, microphones, depth camera. It has IMU. It can move. But in our case, we just focused on one modality, which was the sound. So we just used the sound and developed several applications, which I'll discuss. These are the applications that we developed. The goal is that this robot can be with the person in their home, act as a personal assistant, and if there is any emergency, then it can alert the caregiving system, actual people in hospitals or doctors who can come immediately for help. So again, the focus here for my research was just developing the applications, not the entire framework yet. Today, I'll be going into the details of one of the applications, which is fall detection using sound input. So let's get into the details of how do we take the sound from the environment, from the indoor environment, and detect if there is any potential fall that happened that could be severe for the person who went through it. So this is a paper that we published in 2022, and I'll provide some of the details from this. So what is a fall? According to WHO, a fall is basically an event where a person suddenly comes to on the ground. So anybody can experience fall. It's not age related. But people, as we get older, we tend to be more frail, so the fall can be more dangerous. So, and it is the second leading cause of death globally. So if we can detect fall early, then we may be able to save somebody's life. So that's why fall detection can help. detecting fall, in our case, we specifically chose to use just sound for many reasons. One, because the camera is a little bit intrusive. Nobody wants to have a camera watching them all the time. Secondly, in order to use sound, nobody has to wear anything. So usually there's wearable devices, which some people use. So this one, you don't have to wear any device. But most importantly, we wanted to focus in the bathroom environments, because bathrooms are slippery. And that's where the other sensors that are available, like wearable devices or cameras, are not good approaches, because you're not wearing all the time the device, or you don't want to have a camera inside the bathroom. So that's where this sound can help. So this robot can stand outside of the bathroom and just listen to sounds that are coming from inside and detect something unusual. Again, these are previous approaches. Many approaches exist, but we intentionally chose sound because of the privacy concerns. So our contribution is a non-wearable, non-invasive, and a scalable method. Scalable because the robot can walk around in the house rather than having a fixed sensor somewhere. So we developed a model, a deep learning model, that takes the sound input, and it's able to classify the sounds, whether it's a fall or normal event. For this, we collected our own data set. So getting a fall data set is a challenge, because when we don't have data set available publicly for the real actual fall. So here we have to mimic and collect our own data. So once we have the data, now we need to process the data. So for this, what we call is feature extraction. The feature extraction is basically, so you have this sound, which is just an audio, raw signal, but to make something useful out of this sound, you have to extract information from it. So that's what we call feature. So this is one of the contributions of our work. So what kind of features can you extract? Can you give just raw? This is just raw version of the signal. The only difference is that this is sampled. And here the frequency version of the same signal. So there are several ways to extract the signal and make sense of it. But so in our case, we developed a new feature that anybody can use for sound going forward. So this is the feature that we developed. It's called a diff feature. I won't go into detail. So this is one of the contributions of our work. And then that diff feature, we used to train a deep learning model, a neural network, to learn from those features. And we tested it, and we compared it to existing approaches. So our method, we are able to classify ambient sound from the bathroom environments with 86% accuracy, that whether it's a fall or a normal sound. The conclusion for this project was, so there's a method that is based on just sound, so it's less invasive, that can be used to classify fall events and hopefully save somebody's life. The summary of the overall research, which I only went into one aspect of it, which is the fall detection, but there's more. And they're all based on sound, like a listen bot, which is like a sound classification and localization, which is like, it's able to understand what sounds are in the environment and where the sound is coming from. For example, if there's an intruder, it's able to say it's coming from that door to that door. And then distress detection from speech. So again, when we fall, usually there is some speech. If there is, then it's able to tell from the speech whether somebody needs help or not. And then the last one is just a translation system. So one of the design goals for the project is that research should be inclusive. So here, if the population does not understand the native language, we have the capability of translating it so that the technology is available in more languages than just one. So that's the summary, and just the work that I did as part of my PhD. And there is no research possible without collaborators. So in my case, I had my advisor, Dr. Wee-Sung Shi, and other professors that have really helped me through this journey. Without them, this wasn't possible at all. So research is a teamwork. Thank you.
Thank you. Thanks, Prabhjot. I understood a good portion of it.
Good.
And
That was
good luck on your defense.
Yeah.
That was really good. That's so good.
Very
Lauren, can I have a timer's report, please?
Yes.